The Loy Yang project, the quiet giant of the Latrobe Valley landscape. 2 decades in the making, Loy Yang was the biggest public project in Australia. The site, located approximately 150 kilometres east of Melbourne, was selected because of its proximity to rich seams of Latrobe Valley brown coal. In 1976, the project comprised of a bare patch of ground and a scale model. 20 years later, Loy Yang is one of the main electricity generators in Victoria, pumping 3,000 megawatts of electricity into the grid. Loy Yang A was well into its construction phase when, in 1985, the Victorian government announced formal approval to proceed with the B station. 11 years and $1.8 billion later, Loy Yang B was to become one of the most efficient, economic and high-quality brown coal-fired power stations yet built. Work on the site began in 1987. Major earthworks were undertaken prior to thousands of tonnes of concrete and reinforced steel being laid to form the foundations. In 1988, construction began to creep skyward, with the construction of the lift shaft and the chimney. Foundation work for the chimney involved 108 piles being rammed 20 metres into the earth and capped with 2,000 cubic metres of concrete 30 metres in diameter and 2.5 metres deep, a job that took 4 months to complete. The chimney itself was built using a continuous pour system. There were 3 shifts with teams of about 25 men each working for 10 days and then having 4 days off. The average height poured each shift was 1.5 metres. The chimney took 6,000 tonnes of concrete and 700 tonnes of reinforcing to complete, the job taking 4.5 months. Total height 250 metres. An enormous amount of work was done to improve efficiency of both construction and the various plant systems. The lessons learned from the Loy Yang A project were put to good use at Loy Yang B, and the station is a leaner, meaner version of its predecessor as a result. All major plant components, including the chimney, boilers, turbines, turbine house layout and precipitators, were modified to reduce costs without affecting reliability. In the end, approximately $300 million was carved off the price by these cost savings. There was a great deal of work done to reduce the cost of the boilers and turbines. The boiler structures were refined and the turbines were modified significantly. Instead of double low-pressure cylinders, the turbines were constructed with a single low-pressure cylinder. This was achieved by using 100 centimetre final row low-pressure blades. The end result, a much smaller machine and a money saver as well. In addition to the refinements in planning and design, a major factor in project efficiency was the construction method. In order to minimise erection on the actual structure, a great deal of on-ground off-site pre-assembly of components was done in various locations. At Morwell, Traralgon and the nearby construction storage yard. This construction method reduced costs, site congestion and coordination problems, and improved safety. Off-site construction presented its own challenges. For instance, the precipitators were pre-assembled in the storage yard, as the precipitator foundations were occupied for the boiler construction. The precipitators were too big to be transported in one piece, so they were made in 2 halves. Even then, 52 tonnes of temporary grillage was needed to support the 12 314-tonne loads on a hydraulic trailer, and 3 prime movers were needed to move them the 3 kilometres to the site.
It was quite an engineering challenge to get the precipitator modules up to the bench safely. There were 12 precipitator modules that had to be moved up to the bench and had to be joined together to form 6 precipitators. The foundations had all been pre-prepared and they were just moved up there and then basically bolted into position largely in their final construction format.
Stability was a real concern, as the load's centre of gravity was so high. Wind posed a big risk during the haul. Before any move commenced, the Weather Bureau was consulted to provide a forecast for the next 6 hours, the time it took to travel the 3 kilometres. Once on site, there was another 6 hours of preparation and a further 6 hours to place each section in its final position. Another notable heavy transport event occurred in late 1991, when the largest transformer ever built in Australia made the journey by sea and land to Loy Yang. Built in Sydney, the 320-tonne unit was shipped to Melbourne, and from Melbourne docks, 2 96-wheel low loaders and up to 5 prime movers pushed and pulled the enormous load over 3 days to the site. A total load of 600 tonnes, the largest load ever to be transported by road through Melbourne and the Latrobe Valley. Another large load, this time the generator stator, at the centre of a convoy occupying 3 lanes of the road, travelled at night to avoid traffic problems. Construction at night became a feature during the early days of Unit 2 steelwork. The contractor was anxious to get the core steel up in favourable weather, and the work carried on in 2 shifts, another first for power station construction in Victoria. Once delivered to the site, how were the massive components put into place? The answer lies in the use of the equipment without which this construction method would not be possible: the giant mobile cranes. The use of these cranes spelt construction flexibility, enabling components weighing hundreds of tonnes to be lifted and set down in any given location on the structure. Working to a well-executed construction timetable and utilising the mobile cranes allowed modules to be put in place when it was safest and most economical in terms of efficiencies and expense. Rather than a building, the engineers were designing an enormous machine, and the task of installing the various station components posed some unique engineering problems.
The whole job is a jigsaw puzzle. You've got it's like a battlefield. You've got squadrons of people and materials and equipment to assemble. You have to get them in place at the right time, make sure everything comes together, so when the battle's fought, which is putting the station together, you've got all the equipment there and it comes together in a planned and in a timely manner.
Enormous amounts of preparation was required to lift the modules safely into place. For a technical lift, this could mean up to 10 weeks of planning. The boiler head steel was one such lift. It took 4 weeks to draft the support structures, then a further 6 weeks to build the temporary supports. When lifting these massive beams, nothing could be left to chance.
The boiler head steel was of a different design than Loy Yang A. Loy Yang B was a more complex arrangement. The beams that were erected that formed the head steel were in excess of 80 tonnes weight in some cases and had to be lifted over 100 metres into the air, into their final position. That required a lot of pre-planning and engineering of both the lifting and the access to the lifting points.
Again, weather played a critical role in using the mobile cranes. A load of 100 or 200 tonnes cannot be lifted in wind, so the lifts were dependent on favourable weather. On the day, the lift itself could take several hours to execute. However, with preparation time and the securing of the load at its final resting point, the whole procedure could take up to 10 hours. In October 1990, the weather was to play a central role in the only serious accident to occur in the whole construction period, involving the huge 600-tonne 4600 Manitowoc crane.
Obviously an unfortunate incident. An extremely severe storm blew in over the hill from the Loy Yang A direction and caught the crane, which at the time had a 140 metre boom on it, caught the crane slewing into a park position for safety. The winds, which were in excess of 110 kilometres an hour, toppled the crane onto the boiler structure. Now, 2 things arose from the incident. One was that Transfield, the company erecting the boiler, were able to continue and achieve their program despite the loss of the crane, but far more importantly, no one was injured in the incident.
The safety record on the B project was impressive. Throughout the 9-year construction period, there were no major traumatic injuries. At the start of construction, the target lost time injury frequency rate was 25. In fact, through most of the project's life, figures of 5 to 9 were achieved.
I'm very proud of our safety record at Loy Yang B. On reflection, I believe the introduction of safe work procedures has certainly contributed to our very good record, which effectively meant we all sat down and planned how we were going to do the job safely before we did it.
Industrial relations for the B project was all smooth sailing. The severe industrial problems that plagued the A project were not present with B. At peak construction, Loy Yang A employed 3,000. On B, there was less than half this number. And with an industrial lost time rate of between 1.5% and 2%, industrial unrest was almost non-existent.
The atmosphere on the project was always a non-confrontationalist one, where everybody worked on a basis of cooperation rather than confrontation, which was entirely different from the scenes that were on Loy Yang A. We had a minimum of lost time through industrial relations. We were able to achieve enterprise agreements that truly benefited both parties. And I think at the end result of all that, we have a project completion that both management and workers can be proud of.
I believe the construction workforce at Loy Yang B is the equal of any workforce in Australia when considering productivity, expertise and motivation. And I'm proud of what they achieved and how they went about it.
The Loy Yang project team, operating as an autonomous division of Generation Victoria, numbered 140 and was spread over 2 offices, Monash House in Melbourne, where project personnel handled design and supply, and the on-site team, who managed construction and commissioning.
The project management at Loy Yang is a very broad team. It goes from both from the design perspective, through the procurement, through to the construction, and ultimately the commissioning of the plant. So there's a lot of people being involved in the process, and the chemistry has been one of people who have a common objective, and the objective was to get the job done ultimately. And in the case of Loy Yang project, it's been a very good outcome as far as getting the results.
The strong feeling of teamwork and professionalism present within the project group was boosted in August 1990 when the Loy Yang project gained accreditation to Lloyd's Register, the approved quality management system. At the triennial assessment in 1995, this accreditation was upgraded to cover the new ISO 9001-1994 standard. The Loy Yang team were the first management team in the world to achieve it for building a power station. Project construction consisted of a myriad of tasks being completed and challenges being met, punctuated by a series of major milestones in commissioning. The combined fan runs, the acid clean, the steam to condenser, and the steam to turbine. The project took shape against the changing background of the SEC restructuring process. Privatisation was coming, and in December 1992, the Loy Yang B station was sold to the Mission Energy Company.
Probably the most interesting aspect of the years that I've spent on Loy Yang B was the time of the sale, where I was involved to try and assist in selling the station, assist management in their endeavours to sell the station, by the point of fact that would create work for my members.
The last major milestone in the commissioning of Unit 1 occurred in June 1993, when full load was reached. In September of that year, Unit 1 was transferred to Mission Energy for operation and maintenance, on time and under budget. Steam to turbine for Unit 2 was achieved in December 1995, and in February 1996, full load was reached, again many months ahead of program, and the total project completed for several $100 million below targets set in 1992.
I've been personally involved in the project as an industrial relations and safety officer for 6 years, and it's very good to be part of a project that's ran so smoothly.
It was a pleasure working on the Loy Yang B project, where the project design, planning, organising and controlling came together in such a good manner so that the work did go as we wanted it to.
It's been enjoyable working on the project, and it's an achievement when you can look back and see a power station standing there that's working, that's been well put together and built on time.
Well, I've had a long association with power stations through the valley. I've worked on every one of them that's been constructed, and I would say that the Loy Yang B project was by far the best, the safest and the best industrially.
As I look back in time, the things that have brought the greatest sense of achievement have been the bringing together of the efforts of 1,000 men and women or more, getting all the plant to operate simultaneously and watch the machines roll up to 500 megawatts, and then ultimately the handover to the customer, in this case Mission Energy.
Loy Yang B, the quiet giant of the Latrobe Valley. A major achievement of engineering and construction, it is a testament to all those involved in its creation.